Okay, so we're going to look at another example of metal extraction, but this time we're going to look at it in terms of an electrolysis reaction rather than a smelting type reaction with carbon, because it's possible in some circumstances, such as aluminium oxide, aluminium being a quite reactive metal, that in its reaction with carbon, or more importantly, in its lack of reaction with carbon, this reaction, let's say, won't occur because carbon's not reactive enough to displace the aluminium from the aluminium oxide. So this reaction doesn't proceed, and we don't get a reduction reaction in the normal sense that we've looked at with, for example, copper and iron. So we have to undergo what's called electrolysis. Now, electrolysis occurs when we have two electrodes placed into a solution or a molten source of a compound, an ionic compound. And for the purposes of this discussion, I'm just going to use a very generic metal. I'll give it a 3 plus charge to allow it to be compared to the aluminium above. However, it is possible that this could be done with any metal in theory. So aluminium 3 plus in this example. We could also have done it with the copper 2 plus and also the iron 3 plus that we've looked at in previous carbon reduction reactions. But for this one, we'll just look at a generic metal 3 plus. And what we will do is allow that metal ion to be attracted to the negative electrode. And the negative electrode is essentially negative because it has a build-up or a collection of electrons upon it. And when the metal ion hits that electrode, it is allowed to pick up the electrons that are there. Again, the number of electrons corresponding to the size of the charge. So if we'd had aluminium, we would have reacted with 3 electrons. If we'd used copper, we would have reacted with 2, iron 3, etc., as we saw in those reduction reactions previously. And then this will allow us to produce the metal atom from the metal ion if that metal has been mobilized, i.e., it's a molten or solution based situation, because these ions have to be able to move. This ion in this reaction vessel has to be able to move towards the negative electrode. So there has to be movement able to occur. So there has to be mobility of the ions in the reaction vessel. This will then allow the metal atom to be produced, again by reduction, reduction being the gain of electrons. So we can see that electrolysis can be used in a similar way to reduction reactions using carbon, but this time we can do it in situations where carbon isn't reactive enough to force that reduction to occur. We can now use electricity or electrolysis reactions to make metal extractions proceed. It can also be done, as we said, with any other metal, as we say, copper 2 plus or iron 3 plus. But we have to look at the requirements for that to occur. And obviously, we're using electricity. We may have had to use some heat to make this molten. And so that is then going to increase the energy costs and the viability of these processes. So we have to weigh up sometimes the availability of carbon, primarily. Is carbon freely available? It's cheaper than electricity. Is carbon reactive enough? For more reactive metals, you obviously have to use electrolysis, or an even more reactive metal and just do a displacement reaction, which we'll look at in a subsequent clip as well.